Hello, let's continue our Sudoku adventure with Glued Arrows by PjoeterBliep. So this continues our palindrome theme week. I hope you are enjoying it. This is actually the penultimate puzzle of the week. Cool. So let's go over the rules. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We do have duality here, meaning that our clues here are both of two different constraints. So you kind of combine those constraints together and it has to qualify for both. So first of all, they are double arrows. So the way double arrows work is there's two circles at the end of the line. Whatever their sum is the sum of all the digits on the line. I'm not going to attempt to give an example for this. I feel like it might give away too much because it feels very restricted. But if we sum up these two digits, it needs to be the same sum as summing up these 5 digits. All right. And then in addition to that, they are palindromes as well. So that includes the circles. So that means that digits, when we read this palindrome, forwards and backwards, it reads the same. So for example, 2, 3, 4, 5, 4, 3, 2. So this reads 2, 3, 4, 5, 4, 3, 2 this way, and 2, 3, 4, 5, 4, 3, 2 this way. So another way to put that is digits that are equidistant from the center have to have the same value. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so what is the minimum this could add to? We could put what you want to do when you're thinking about what is the minimum, you want to think about grouping together as many cells as you can in a row, column, or box, kind of greedily. So we can greedily take these 3 cells, we're looking at this whole line, as one group, and then we can take these 2 cells as the remaining group, and they share a row, so that's why they're a group. They also share a box. We could have also done these 3 and then these 2, but we're just picking this. And so this would be potentially 1, 2, 3, and this could be 1, 2. So the bare minimum this adds to is 6 plus 3 is 9. Now, we do know it sums to an even value, which is interesting, because these 2 are the same digit. So the minimum is actually 10, meaning this is 5 or 6. Now, if you think about it, these 2 are the same, and these 2 are the same. And so that's going to be even no matter what, because this is 2 times the value, and this is 2 times the value. And so this needs to preserve our evenness, because we know that the total sum is even. So this is a 2, 4, or 6 in order to do that. We have to be even in order to preserve our evenness. All right, let's look at the minimums here. We've got this guy, which could be a 1. We've got this guy, which could be a 1, 2, and then this can be a 1, 2. So this is 3, 6, 7. Actually, minimum 8. So again, we're going to be an even sum for our double arrow. So this has to be even as well. And our minimum was 7. So these are 4, 5, or 6. So they add to 8, 10, or 12. Okay. Let's see. What do we do next? Do we need to color? These 2 are the same digit. They could go here. I want to think about whether this can actually be 6 because it feels too big. So if we recall, let's do it this way. This could be... Oh, right. So, okay, this can't be a 2, I think is the first thing that we can say. I think. So if this was a 2, then now none of these are a 2, meaning I could do a double 1 and a double 3. But that's going to add to 8 plus 2 is 10. Wait. No, that's perfectly fine. That adds to 10. And so then with a 4, we could actually do double 1 and double 2. And so that would add to 6 plus 4. That would add to 10. With a 6, it would add to 12. So 2, 4, 6 is all possible. I do believe 2, 4, 6 is all possible here as well. Okay, so that's a bust. All right, maybe I do need to start coloring then. What can I do? These 2 are the same digit. We'll call that green. These two are the same digit. They're definitely not green. We'll call it purple. These are restricted. The ones that repeat are restricted, aren't they? They have to be smaller than green. Anyway, this we'll call orange. We know it's different than purple and green because of this box. Now, purple plus orange is less than green. For sure. Purple plus orange is less than green. So even if green was 6, they have to add to 5 or less. So they have to be from 1, 2, 3, 4, I guess is the point. Now, green is one of these two. Could it be in both of these? Maybe. If it was a 4, I think that would be fine. Now these, if this was a distinct digit, it would go here. And that's no good. Because that would mean that these two summed the same as these two, but these would be the same digit. And then we'd be adding these to it as well. So that would, remember that these need to be smaller than these. In fact, the sum of these two is smaller than this. So I think 1, 2, 3, 4 is valid to put here as well. And so this 5, 6 actually has to go here. This is green. Yeah, if this was a 5, we'd already be at 10, and these would have to get us to 12. There's no way that's happening. So if these are 8, to get to 12, we would need 4, which we could do with 1, 1, and 2. Okay. So anyway, this needs to go in this box somewhere, and it can only go here. So this is green. And that means that this is not a 4. This is the same 5, 6. And so it goes here or here. Okay, so now we know green can't go here because, again, these are smaller than green. Much smaller. And so this is green, which forces green to be a 6, which doesn't surprise me too much. All right, so those are all 6s. And that means that these 4 need to add to 6 in total. So these add to 3 and these add to 3. So this is a 1, 2 pair and that's a 1, 2 pair. Okay, so 1, 2 pair tells us that orange is not 1 or 2. It also tells us that this is a 4. So that makes orange a 3. So we know this sum then, because these add to 6 plus 4 is 10. So these both have to be 1s. That's 2 and 1. That's 1 and 2. All right. I don't need the colors anymore. They're all digits now. So we can just Sudoku it up, I guess. This is our 2, and this is a 5. This is a 3. Up here, we need 4, 5, and 6. The 6 goes here. This is a 4, 5 pair. Over here, let's see. This pair is a 4, 5. No good. All right. This pair is a 2, 5. This can't be 2. So that's a 5. That's a 2. That's 4, and that's 5. This is a 4, and this is a 3. All right. Over here, but 3 in the corner celebrating. Over here, we need 1 and 2. The 2 tells us that's 1. That's 2. Over here, we need 3, 4, 5. All I know is that's not 3. All right, this is also 3, 4, 5, but not a 5, so it's 3, 4. This is just 2, 3, 4. The 2 can't go here or here, so the 2 goes here. This is not a 3, so this is 4 and 3. That's 5, 4, 3. That's 5, 4. Our last 2 digits are the 1 and the 5. That's 5. That's 1. And we're done. All right, cool puzzle, PjoeterBliep. That was really interesting to think about. I think the key step was knowing that this had to go here, and then it couldn't go here. So we got them all as 6s, and then it kind of just resolved from there. That was neat. All right, well, let me know how you did, and if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.